Well, so this is the number 24. So on the 2023 AMC 10A. So this one meant to be really challenging, but in my opinion, this was actually easier than some of the previous problems on the test. So maybe it's not the case for most people, but let me show you what I did. Okay. So we are given six regular hexagons inside of another regular hexagon, and the larger one, it says one side of the smaller one is 1 unit. Okay. Okay, so that means this piece is one, so this piece, like this piece, is one, right? And each block lies along the inside of the edge of the frame that is aligned with the two other blocks, which is as you see. And distance from any corner of the frame, which is like this distance, is given 3/7 over this distance. And based on that, what is the area of the region inside the frame not occupied the blocks, which is basically the shaded region should be subtracted from the larger hexagon. Okay. So before we get into this, I like to remind two things. One is the area of the equilibrium triangle formula. So a lot of people already know this one, but it's good to remind because this is the AMC 10, like A number 24. So if you are doing this problem, so you should already go with this one. But when you have a equilibrium triangle, the area basically the x squared times √3/4. So this is something you can get immediately if you drop the altitude using the 3690 or Pythagorean, but it is good to know it because that will be useful in most cases. So that is one of the places right now, okay? So the second thing I like you to remind is whenever you have a regular hexagon, let's say this is the one of these, right? Okay, so let's say this is the regular one, which doesn't look like, but so when you take a point in the middle, which is right in the middle, and you connect with each vertices, okay, so you will actually get 6 equal area, and then all those triangles will be equal triangle. And if you don't know why this is the case, just review the polygon like relations in the angles. If you find the angles for each one, so that will be 120, that will be 120, 120. And if you do connect those, you will actually see all of them will be 60s. But that is another time to talk about why that's the case. But these two are actually something I like you to remember. So you are going to split into 6 equal triangles. Okay, so that's the area formula for the equalizer triangle. So let's go back to the problem now. So what we know is the like some fraction, right? But at the same time, we can handle these somehow. So let me put those back. So if I take like one of these regions, which is like all of them are identical. So if I know the one of these region, I may find the other one easily. So, but the inside angle right here, so maybe I should make it a bit bigger so you can see. So the angle right here, give me a second, yeah. The angle right here is 120 because this is also regular hexagon, and this is 120, which is forcing this angle, and this angle is 60. So which looks like nice idea, good idea to try extend this segment. If you do so, you will get something like this. So this is 60, so that means this is also 60. And now we know the inside angle right here is also 120. So the outside right here, exterior is 60. The same goes right here. This is 60, this is 60. And this was 120 because that's one of the edges of the larger hexagon. So this is 120. So this is also 120. There is an isosceles trapezoid right here. So I will draw this bigger so you can see how that looks like. But at least this is the case. Okay. So let's go back to original picture. Okay. So now let's take those a bit. So this was the case. So if you draw the isosceles trapezoid, so it looks like this. Okay. And what we know is you know, the each piece right here was 3/7. So which means this is 3/7. This is 3/7. And what else we know on this one? So this piece is 1. So the larger piece is 1. And I also know this is 120, which is this was 60, and this was 60. So whenever you're 60, we can drop the altitude. And same thing right here. So that should be 30 degrees, and this is also 30 degrees, right? So if you remember 36 to 90 degree, the hypothesis actually double out the leg that is opposite to 30, which is going to be half of 3/7 is 3/14. And same thing right here, 3/14. If you subtract these two 3/14ths from 1, so you get this middle region. So let's write that. 1 minus 2 copies of 3/14, which is 3/7, right? So that should be 4/7 when you subtract from 1. So this is 4/7. And then this is 4/7. Okay, so this is something we have right now. And if you know the area of this region, which is not harder to do so, and area of this triangle, we can find those places, but we need to find this middle region as well, which is also something we can handle it, but I'm not going to do that much work. Instead, since I already know this side, so I can find the area of that shaded region, which is a regular hexagon, and I can try to find this leg, this side of the larger hexagon, which I already know that as well, because this was 4/7, so which is like basically this piece is 4/7, and I do know this was 1, so which is forcing this to be 1 as well, because this is a equilateral triangle, and then this is also 1, and this was 3/7. So if you add those, 3/7, 1, 1, and 4/7, that will be another one, so which is just 3 units, which is nicer. So which tells you this side is 3. Okay, this side is 3. So if you find the area of the large hexagon, which I mentioned at the beginning, that is 6 times equilateral triangle. If you drop the triangle like this, so the area of this triangle will be multiplied by 6 to get the area of the larger one. So 6 times area of this triangle is 3 squared times √3/4. And minus, I will subtract area of this hexagon, but we have 6 of these, right? But every 6 smaller hexagon has also 6 equal triangles, 6 equilateral triangles. So the one of them has one side is just, if you remember, this is 1. So we have 6 of those equilateral triangles. So 1 squared times √3/4. So make sure you have 2 6s. And if you subtract these, that will be actually for your final answer. So you can handle this on your own. So that should be 9√3/2. And that's the final answer. So I hope that makes sense. So this is just the my first approach, but there are some other ways you can actually handle this question, so which I will leave for you as a challenge. Okay, I'll see you next time.